Well, we're going to start a video on the construction of some sawhorses. Seems like trivial enough, but yeah, not everybody's got a good set of sawhorse plans, and you know, it's a set of sawhorses is about the most useful thing you can have around your house or garage or shop. So these are sets that we've built, and we'll show you how to go about building those, how to go through the process. In this case, I'm using it's treated lumber. In my opinion, they're going to spend some time outside. Treated lumber is just worth it. The difference in treated and untreated lumber for this project is very, very low, very, very small. The effort's, you know, more than the cost difference. So I don't want to do it again for a while, so I'm making them out of treated lumber. These sawhorses are 30 inches tall, 36 inches across. You can certainly make them any dimension you want. We'll talk more about that here in a bit. I have a spreadsheet that I use that basically gives me the dimensions. Not everybody will have access to such a spreadsheet. Let me know if I can help you with a set of custom dimensions. I'll be glad to do it. Anyway, so let's get to building these things and see how they turn out. So here's the calculations on building the sawhorses. You can see that the width I chose is a 36-inch wide sawhorse, 30 inches tall, and that comes with, when you do the calculations, these sawhorses have about a 16-degree angle. The angle's fixed without regard for the height or width. You can just assume 16 degrees for your angle cuts to make your legs match the ground. And then, actually in this case I've calculated that the leg length should be about 30 and 7/16 to make a 30-inch tall sawhorse. Now, it doesn't really matter. If you cut that leg length 30 inches, you're going to be real close to 30. You cut it 31, 32, you're not going to be that far off. But I actually needed to make some sawhorses specific heights, and I'll show you those later. And so I actually did the calculations, did the trig, and figured out how to calculate the actual leg length. So to make a true 30-inch high sawhorse, you need a 30 and 7/16 inch leg length, and we'll see more how that works out. And then down here you'll see I've done a little bit of calculation using pricing that I paid for wood yesterday. And so the total wood, we got 5 sticks of 2x4 by 8 foot stock, $377 each, and then one 1x6 by 8 foot at $797 each. This is basically from a major DIY store in my area, and it came up to about $26.82 with tags. Came just short of $30, and that's not counting, you know, screws, fasteners, those kind of things, but close enough. So over here on this side, you'll see there's the here's the list of bill of materials. Basically, I need 4 2x4s, 34.5 inches long. 8 2x4s, 30 and 7/16 long, and that's with the angle cut on one end, or on both ends, 16-degree angle cut. 1x6, 2 of them 36 inches long. 1x6, that actually should say 4. Apology for that. That's a 4, 5 3/4 inches, and those are for the end caps, and I'll show you those as we get there. But we actually need 4 of those, not 2. It's 2 per sawhorse, and we're going to make a pair of sawhorses in this project. So that's the calculations. Hopefully you can capture that if you need it, but that's what we're going to build. This again is for a 30-inch tall set of sawhorses. You can adjust this leg length, or you can adjust the widths to make a wider sawhorse, taller, shorter, whatever. And again, like I said, I'll show you a couple of shorter ones that I produced, actually specific heights for a truck restoration project I'm doing. So let's get out there and start cutting some lumber. So we're going to begin with our angle cuts. You'll notice that this is a compound miter saw, and you'll notice that this angle's kicked over 16 degrees. You can't read it, but I can. Right here it says 16 degrees. And so we're going to start cutting those 30 and 7/16 inch pieces. So I'll let you watch a couple of them, but I won't bore you for long. This first one is kind of hard to hold the board on there, so I'm cutting it a little proud, and we'll trim it off on the other end in just a minute. So here we go. So we're going to measure 30 7/16 from the end. And then we're going to cut it. Keep on doing this. You maintain that angle on one end and just cut the angle on the opposite end. Alright, so there's one. Notice angle, angle. So when it leans against the sawhorse, this should be flush on top. So we're going to cut 8 of those. I won't bore you with them all. We'll come back when that's done. Alright, so we've got all 8 of the legs cut here. Now we're going to cut the cross pieces. They're going to be 4 of them out of 2x4s, 34.5 inches long. So let's go ahead and get started on that. You with it all, so we're just going to cut them all up. Okay, so we're going to cut the next piece, next 2 pieces, which is 36 inches long, and these are the top plates of the working surface for our sawhorses. So let's cut those, and then just a couple more pieces to cut after that, and we'll be done. We'll get back with you. Okay, so we've got the 5 3/4 inch pieces, 4 of them. And I saw before in my spreadsheet I was mistaken, it said 2, but there's 4 of them, and those are cut. Those are the end caps. The reason they're 5 3/4 is not because it's relevant for the size on the sawhorse. It's because that's what you're able to get 4 pieces out of the remainder of an 8-foot stick after you cut your 2 work surfaces at 36 inches. So all the materials are cut. Now we can begin assembling the sawhorses. Alright, we're going to begin construction. We're going to begin the construction by making the I-beam top piece. And I start by putting together the 2 2x4s. Let me show you how that goes. I'm using 9 by 2.5 inch deckmate screws for a couple reasons. One, I like the positive grip of the star bit, and 2, they're 2.5 inches, and it's generally enough for what we need on this project. You could certainly use larger 3-inch, but I don't think it's terribly necessary. So on this bottom piece, or on this piece, I'm going to start with 4 screws. We'll put 2 on the ends, far enough away from the ends to prevent splitting, and then distribute 2 across the middle, and 4. 4 is plenty for this particular part of the sawhorse. And once we have those started, what we've got to do is we need to center this piece on top of this piece. Now, if there's anything accurate required on these sawhorses, this is probably the most significant place where accuracy is relevant. So you should have about 1 inch measured in from each side, maybe 1 inch and 30 seconds, something like that. But you want this to be fairly even. I'll show you why, but in a minute. But basically, this fixes the angle of the leg, and you don't want the angles to be significantly different. Otherwise, you get some really awkward-looking sawhorses. Well, sawhorses would still work, quite fine. Make sure the ends are flush. Okay. I always like to recheck this dimension to make sure it didn't slide out too far. If we did, we can correct it. But it's looking pretty good there. So go in with this screw, and then the remaining two. And once that's complete, bottom part of our I-beam is done. Flip it over. Now we put on our top piece. Top piece is the work surface. This 1x6. And so what we're going to do is we need to split the distance in several ways. The easiest way to do this one on the ends is just to use a piece of the 3/4 stock, which that's too tall. A piece of scrap, and we'll just use this scrap piece of 3/4 stock to set this thing lengthwise. Should be 3/4 on each side. Or split the difference if you're if the cut's a little long. So just so it's close, it doesn't have to be exact. And then you can check your dimensions here. This way we have 2. This direction we have 2. Goes over, so we're pretty close. So then we'll do the same on this end, looking for 2 inches here, and that should be centered. Now, the top doesn't have to be centered as much. The bottom piece is the one that sets the angle of your legs, and so you want that one. You want to spend a minute or two to make that one centered. Now, in this case, I'm going to use 3 screws, dead center here if possible. One of the very convenient things about these sawhorses is when you get done, as you are using the sawhorses, you cut through, maybe unintentionally, but you cut through this top board. All you have to do is remove those 3 screws, and you can replace that top board and basically have a near new set of sawhorses. So, get this screw in here. And then one in the middle. Okay. So the I-beam portion is done. Basically our legs are going to attach here at angles. And it's just that simple. This board's replaceable, which is nice. And so that's one of the reasons we like this design quite a bit. So, offline, I'll make the second I-beam, and then we'll start assembling one of these things for real. Okay, so we have both I-beams put together. Here's one back here. Now we're going to begin by installing the legs. If all works well, they pretty much just fit. And so I've started the screw here. We're going to put that one in. And I'll show you kind of more what we're looking at. You'll notice the angles fit pretty well, and this is where I was saying that this measured wanted to be even between sides. This is what controls your leg angle, so you want to try to make that 2x4 on that I-beam as centered as possible. So once we have one screw in it, I just check and make sure that the alignment feels good to the end. We're just butting it to the end of the I-beam, and then we're going to put in some more screws. I usually use 4 screws on these legs, 2 into the I-beam, the centerpiece of the I-beam, and then 2 into this lower piece at a bit of an angle like this. There we go. And we just screw those in just like that. So you can see pretty quickly your sawhorse. It's coming together. Feel free to bury these screws as deep as you want. 1.5 inch worth of material there. You got plenty of room. So one leg on. So one leg's on. Let's do this other leg while you're with us still, and then I'll take it offline and do the rest. Notice the angle. The angle should fit at 16 degrees, pretty closely. Not necessarily a perfect fit. I mean, the actual dimension's a little less than 16 degrees, so don't worry if it's not quite the perfect angle. We're not trying to make a miter joint for a picture frame, so I just kind of eyeball where I'm going to put that screw, and then start a screw in there. Definitely easier going once you have a screw started. Enough hands otherwise. So we'll get that roughly lined up, which it is. Okay. Now once it's stuck in there, now we can manipulate a little if we need to, make it just as right as we can get it, which it is. And then that one goes in the bottom 2x4. This one too. And I do like to bury these a ways. That much more grip keeps them out of the way when you're working as well. So there you go. There's one half, one side, and then all we're going to do is flip it over and around and do the other same thing on this side, one leg at a time until you're done. So I won't bother you with more, but you can kind of see now what's going on. So let me go finish this up and then I'll get back to you. Okay, so basically we're done with the primary part of the assembly. The legs are on. It is sturdy, doesn't wobble. The feet are angled so it has nice square footing on the ground. The next thing we want to do, and this is totally optional, it's up to you if you want to do it, and you can do it several ways. I generally like to do it for one reason: it makes them stack better, and for another, it just gives them a little added strength, and that is I like to put an end cap on the end of this I-beam right here. And what that's going to do, that's what these 5 3/4 inch pieces were that we cut a while ago. And what that does then is that just allows you to use some screws and just basically tie all the primary members together. And so what I'll do is I use, and these are 1 5/8" screws. We don't need 2 1/2s for this. And I try to hit all the primary members. This is the bottom 2x4 on the I-beam, and then this is the central 2x4 on the I-beam, and then I'll put one in each leg. And again, it just helps to reinforce the connection between the leg and the I-beam. And you will see that it doesn't necessarily line up 100% on where it meets with the legs, and that's because even with working to keep that dimension between the two, this dimension even, you always have a little bit of kilter in the legs. They're sawhorses, not living room furniture, so I do not sweat such as that. So you know, everything has a purpose, and everything's built for that purpose and that purpose alone. So again, we'll go into the center 2x4, and then we'll hit this bottom 2x4, and then into these two side legs. And you can put more screws in than I am. Up to you. In my experience, I've built them without these plates, and they can hold elephants. These things are sturdy, very, very sturdy. So that one's done. Now I stand it back up. As I said, it sits well on the ground. Would be disappointing if it didn't. So we can take this one, which is the second sawhorse, and we can then just set it right on top. They stack well, so generally that means they store well. I don't know. If you need sawhorses, this set cost me 30 bucks if you count screws. 2 sawhorses, thin, lightweight sawhorses at the same discount DIY store. Very poorly constructed as far as I'm concerned, as far as quality and strength. They were 20 bucks each, 20 bucks really cheap. The plastic ones don't hold nearly the load. They tend to want to break over time with weathering as the plastic hardens. These wonders are useful, convenient, they travel well, they stack, and again, if you use treated lumber, I'll store these outside. With this treated lumber, they will last many years. I also tend to paint them, not intentionally, but whenever I use them to support materials I'm painting, I'll often end up coating with paint, maybe emptying out the remains of the paint bucket or the paint can, spray can, if it's just a bit. Nice wide work surfaces. Love these sawhorses. I hope if you need them and you build them, they turn out as useful for you as they do for me. One thing though, before I go, let me go show you these other sawhorses that I was talking about earlier, where I made the sawhorses to a custom length for a specific application. Well, pardon the mess, but this is a truck frame for a 1951 Ford F1 pickup truck, and it's in the midst of being reworked right now. You'll see tons of metal waste on the floor. There's a front suspension on its way out, and so basically we've stripped the suspension, all the suspension parts, all the excess attachment points on the frame so that we can start over again basically. But in order to work on this thing, in order to weld up what I need to install these suspension kits and things, I need to have the frame level. Now level in this case is in this section right in here. You'll see it dips down in the front, it humps over the wheel in the back, so you got to pick that flat spot in the middle. But you need a level. Level for this frame is about 1.5 inches difference between the point where you see this sawhorse and the point where you see this sawhorse. Now these sawhorses are quite small. They're intended for that. We don't need the frame 30 inches off the ground. I think the highest one's maybe 20 inches. So, but what I did was I basically just built two sawhorses of different length, was able to calculate the specific lengths. If you need a different length for your legs to get you a specific height for your sawhorse, let me know. I'll be happy to help you calculate that. There are applications like this one where I needed a specific height. I needed this one to be basically 1.5 inches taller than this one. So that now that it's up there, I may have to shim a little, but it'll be very little. It's pretty much level front to back. Let me see if we can see how level it is front to back. Here's our angle finder, and pretty close to 0 in my book. So by having these sawhorses specific dimension, that allowed us to pretty much level up the frame and get it where we can weld on it. So thanks for watching. I hope you if you need sawhorses, I hope this works for you. If I can do anything for you, yeah, just give me a shout, drop a comment, rate, subscribe, whatever you like to do. Be happy to help you out. Thanks. Bye-bye.